Hello, Brother Wilson. This is Megan Showers, and I will be presenting my Week 13 encryption or Cipher project. So here you can see the Lab13 Py file. I chose to do mine in Python, so I'll go ahead and go over to the Cipher and do a brief explanation of my Cipher, and then I'll go through and provide the demo. So here you can see let's go ahead and go to the top. So here in the Cipher, I've just added a little point for the alphabet and a point for the symbols to go through in a for loop, which you'll see in a bit. Then I have the get author, get cipher name. I will be presenting the Autokey cipher. And here's my citation. So in my pseudocode, I provided the start, the declarations of strings and characters, as well as the for loop that you'll be seeing in the encryption. And then the same, very similar to the encryption pseudocode, is the decryption pseudocode, which also shows a declaration of strings and a declaration of characters, as well as the for loop, where I go through the length of the ciphertext, unlike the encryption pseudocode, which went through the length of the plain text. Down below, you'll see the actual encryption itself. Let me pull that out. So here in the encryption, you can see that I am declaring some strings, and then I go through for the length of the plain text provided by the user. I assign a character to both the plain text and to the password or the stream key, so that I can identify each of those characters, and ORD being Python's a built-in function for pulling the ASCII character value from the character itself. So that's what it's going in this for loop. Then from there, I'm converting it to the character after going through the given, this provided my pseudocode, the given first and second, so the plain text and the key, the first and second characters modulo 26. And adding it to the cipher itself. Then at the end of the for loop, it returns the cipher. So that is how my encryption code is working. Okay. I really hope I'm sharing audio, because it just occurred to me I might not be. We'll just keep going and see what happens. Okay, sorry. So decryption. So for my decryption, you can see that I am establishing that the plain text, which is what ciphertext will be converted to once it's decrypted. The plain text starts out empty. Then I go through the for loop, going through each of the characters within the ciphertext created by the encryption. From there, similar to the encryption, I'm going through and finding each character from the ciphertext and the password. I'm using the ORD function from Python for the ASCII value, and then I'm using the same formula but inverted for the decryption. And then I also have a check here to make sure that the total is correct. Otherwise, I have to add 26 for the alphabet for it. And then from there, I'm comparing it, adding the total character to the plain text and to the password. And then I return the password in order to, return the plain text, which would be the decrypted ciphertext. And so that is how my code is working. I'll go ahead and demonstrate a demo. Let's see, I need Zoom to move. Here we go. And run without debugging. We'll just go ahead and pull this guy up here. Scroll to the bottom. Actually, let's clear it out and just go from there. Oops. Stop. Clear, so we can have a blank terminal, then run without debugging. So I'll enter the text, plain text, enter my password, and here you can see my input. Please enter the text, plain text. Please enter the password. Then it has the cipher name. Again, I'm demonstrating the Autokey cipher, and my name, Megan Showers. And here's my citation. And then here is the plain text, as you can see, the ciphertext as well, and the deciphered text, which matches the plain text. Here's the pseudocode, which I demonstrated, well, which I explained prior to my demonstration, as well as my decryption pseudocode, again, previously explained before the demonstration. Thank you very much for watching and have a fantastic evening.